The question of the advanced SAT function will gonna be the quadratic function y is equal to ax squared and the linear function y is equal to mx plus n intersects together in the coordinate plane at the points A and B. Point P on the segment AB's x coordinate is P, where P should always be greater than 0. Solve for A, M, and N and express PQ's length when point P is 6, 12 and point P is perpendicular to point Q. So this question is basically asking us to solve for our unknown variables A, M, and N through our functions, and our another equation in this case will be expressed PQ. PQ will be a point and its length when point B is 6, 12. So in order to solve for this question or approach this, we basically have two or basically four solutions or things that we need to know in order to solve for this question. So let's get through it before we approach this question. So the first thing that we're going to talk about is types and definition of vertices in the quadratic function, but we can think about it through our second one, which is optimization and effect of standard form and variables, because both of them are related. The standard form, which is the most important or the most basic format in our quadratic function, its format will be y is equal to a times x squared plus bx plus c. This will going to be what the standard form will going to be. And let's think about what is standard form optimized. Well, the first thing that is standard form optimized will be a calculation. The standard form is optimized for the calculation. The reason is because we know that standard form is usually ordered in a descending order, which means we can think about every single variables or constants in a one spot. So we can think about the calculation in the easiest way in the standard form. So the standard form is optimized for our calculation, and the most important example for a calculation will going to be y-intercept. So it will going to be our y-intercept. If you don't know what the y-intercept is, which is the one of the example for a calculation system of our standard form, so basically there are two types of intercept. So if you think about what the intercept is, there are two cases of our intercept. The reason is because we can think about intercept through its definition, and its definition is there is a point on the axis. And we need to focus on the word axis. How many axes are there in the quadratic function coordinate plane? Well, there are two axes, x-axis and the y-axis. So basically there are two types of our axis, x and y. So firstly, let's think about what is our x-intercept. Well, as we can see, the intercept is a point on the axis, which means the point is on the x-intercept. Which means when you convert this into some specific coordinate, it will going to be x, and we know that the x is equal to input of specific function, which means when the x value, our input, exists on our quadratic function system, our output of our function, which is 0, which we call it as the y, usually will turn into 0. This is what the x-intercept will be. Secondly, let's think about what is the y-intercept. Y-intercept is exactly same kind of concept with the x-intercept, except the x input will turn into 0 because the point is on the y-intercept, and the output of our function, which we notated as the y or f of x sometimes, will exist. And the reason why we just notated as the x or y, not a specific value, is because we know that x and y values are the variables, which means they changes or varies depends on times. That is the reason why we noted x and y as a variable, x and y. So there were two types of our intercept, and the y-intercept was the most important calculation systems example of our standard form. But when it comes to talking about the standard form, there is one bad thing or a negative point about the standard form. We know that the vertex is the most important thing when it comes to graphing a specific graph of our quadratic function, because if we don't know the vertex, we won't be able to solve for our graph of our quadratic function. And every single coordinates on our coordinate plane will be formed by the x, comma, y, where the x value is our input and our y value is our output of specific function. And the vertex is one of the example of our coordinate. And for the standard form, there is no way to solve for our vertex, which means there is no way for us to solve for the vertex as well as the graph of our quadratic function in the standard form. So there is a way to solve the vertex. In order to solve for the vertex in the standard form, all you have to do is simply apply our formula for solving for the vertex, or we need to convert our standard form into some specific format or the form of our quadratic function in order to solve for our vertex, which is the most important thing in our quadratic function system. We talked about what the standard form is optimized. It is optimized for the calculation, especially for our y-intercept. And now it's time for us to think about what does each variables or the constants in the standard form is optimized for. Firstly, let's think about what is our y and x. And we know that our standard form is again y is equal to ax squared plus bx plus c. We're thinking about what is the y and an x, because y and x will be variables, the main example of our variables that we commonly use in our quadratic function. Well, the y and x, each of them will be each output. Y will be the output, x will be the input of our specific function, and they are the thing that actually generates our quadratic or even some specific functions. If there is no output and input, we won't be able to call it functions. If there is no output and input, we'll just call it an equation. That is the reason why y and x is the most important element in the quadratic functions or different kinds of functions too. Now let's think about another most important, we can say constant, which will going to be a. What is the a? So the a is a coefficient of the x squared term, so it will going to be a leading coefficient. The a value, which is a coefficient of our x term, will be a leading coefficient. Now we can say that why does a is more important, because we know that the x, a, y, and x are the most important thing. The reason is because it is related with our vertex. Because vertex is the most important, I guess, the basic in our quadratic function, because in order to form a function, we need a vertex. And our a value is leading coefficient. If you just think about what does it mean by a leading coefficient, the difference between just a coefficient, and a leading coefficient will be defined by the word leading. The reason is because the leading in the leading coefficient is a short word form to show the highest degree power term, x squared. We know that the x squared is the highest power term in our quadratic function. And the leading terms coefficient, which means we know that the coefficient will be the constant beside the variables. In this case, the leading variables constant which we call that's the leading coefficient. And the reason why it's important is because it is a thing that actually defines our vertex of our quadratic function, and we can talk about it specifically later. Now let's think about the second one. What is the b? Well, what is the b? Well, the b is exactly the same kind of concept with our a value, except b value will be a coefficient. B value will just going to be the coefficient, not a leading coefficient, unlike the a value of x to the first power term. This is going to be what the b is. It is a coefficient of our x first power term. Now let's think about what is our c. Our c value will be our y-intercept. The c value, which we call it as the constant without a variable, will be a y-intercept. And we'll be able to prove why the c value is our y-intercept through its definition. We know that the y-intercept means, according to the thing that we learned here, when the x value is 0, our output of our function exists. And this is what the b and c are. But b and c are a little bit different. And the c value is, we know that all we have to do in order to solve for c values is input our x value as 0 to our quadratic function. In this case, quadratic function is our standard form. Y is equal to a x squared plus bx plus c. This is what the standard form is. All you have to do in order to solve for our c value is simply input x is equal to 0 to our standard form. If we do it, we're gonna get y is equal to a times, instead of x we input 0 squared, plus b instead of x we input 0 plus c. If we calculate this situation, we'll be able to get if the c is actual y-intercept or not. So let's actually prove it. So there will be just a y, and we know that y will be the case when x is equal to 0, which means something that it will going to be our output will be y, which means it will be a y-intercept when x is equal to 0. So if we calculate this, 0 squared will turn to 0 times a will obviously going to be turned to 0. So let's write it smaller. Plus b times 0 will turn to 0 plus c. And this will eventually turn into c. And we know that 0 plus 0 doesn't make sense because it is not an actual number. So our y value, which means the number that will occur when our x value is equal to 0, will be c. That's why we say c will be our y-intercept. The ability here is make the numbers smaller for the spaces. And now let's think about specifically about the a. And so it will be related to our vertex, but especially going to be the types. And through the a value, we'll be able to solve for our first thing that we need to learn already know in order to approach this question, which will going to be types, as well as the definition of vertices in the quadratic function. So the types of our vertex will be defined by the signs of our leading coefficient a. And there will be obviously two cases if you look at the word sign, because they can be either negative. In the sign, there can be either negative or the positive value. So through these things, let's think about the types of our quadratic function's most important thing, which is our vertex. So let's erase this a little bit for our spaces. And the first case will obviously going to be when our a value, and what is the a value again? It is our leading coefficient. when the a value is positive value, which means when it is greater than 0, it will operate. When it is greater than 0, the graph of a quadratic function will always operate according to its property, as we have learned in lots of videos, and it will look something like this, that keeps going toward operate, never intersects at a specific point. But then it will contain most important point in our quadratic function system, which we call it as the minimum, or the lowest point on our graph. And we can obviously know that this situation will occur when our a value, our leading coefficient, is greater than 0, when it is positive value. Now let's think about the second case of our vertex in our quadratic function. When our a value, which is our leading coefficient, when our leading coefficient is less than 0. When it is less than 0, it will obviously going to be a negative value, unlike the first one where it was positive, which means the graph of our quadratic function will open downward, unlike the first one, which is the exactly opposite with the first one. When it is going downward, it will look something like this, that keeps going toward downward, and it will contain another most important thing in our quadratic function system, which we call it as the maximum, or we also call it as the highest point on our quadratic function. And as we can see, it will occur when our a value is negative value. And from these types of our vertex, we now can think about what is the definition of our vertex of our quadratic function. Well, it will be a number of possibilities. The possibilities addition between the minimum point and the maximum point. So the definition of our vertex is it is addition between the minimum point and the maximum point situation, which means we can also say that it is the addition of a values. What a values? A values sign. It is essentially going to be same with the number of possibilities, minimum, maximum point, because they are the thing that makes our two types of our quadratic functions vertex types, minimum and the maximum point. So this was the first thing that we have to learn, types and definition of vertices in the quadratic function. Now let's go to the third one, which is the effect of perpendicular to points on current plane, which is the given thing on our information. But perpendicular in this case is not important, so let's go to the next one, and we'll think about the perpendicular one while solving this question. So ways to solve the unknown variables in quadratic functions. In this case, we can also think about it through solving this question and think about what should we do in order to approach these questions. So now it's time for us to actually apply these things that we talked about into our real life question. Firstly, let's think about every single information that we're given. So we have our quadratic function, y is equal to ax squared. And we have our linear function, which is y is equal to mx plus n. mx plus n and the ax squared will be the examples of our functions case, but there are different types of function, where the first one is our quadratic function and the second one will be our linear function. So let's write it down again in a neat way. Y is equal to ax squared, our quadratic function. Y is equal to mx plus n, which is our linear function. So we need to have some information from here. Before that, let's think about the points, which is the basic structure of our coordinate plane. So there are, they said they have the point A and B, and they intersect these two quadratic and linear function intersects together at point A and B on the coordinate plane. And for the A and B, the B is given. B point will be, according to our equation, it will be 6, 12. And obviously we know that according to the x and y, when the input of our function, which we notated as the x value 6, our output of our function of our point B will be 12. And if you realize where the point B is, it is right over here that I'm pointing out on the graph. So we can think about in this way. The point B is the intersection of our two functions, which means if we input point B, one of these functions, they should both satisfy and they need to have an exactly same output when you input some specific values. Exactly specific value are 6. This is the most important point when it comes to solving this question. We call it as the simultaneous equation, as we have learned in a lot of videos. What is the simultaneous equations? Well, as we can see in a lot of videos, and we proved it also, it is a specialized equations for solving for the unknown variables. It is a equation for solving for the unknown variables. But in this case, we can use it in this way. We know the simultaneous equation is when the two functions contain exactly one point, which is B, and also they also have A. If we input specific values 6 into both of our function, they need to give us specific output, same output 12. This is what it means to our both intersection. This is what the intersect means. Let's think about, we can think about in this way. So we need to solve one of our function, and we can solve it through y is equal to ax squared through our point, because there is only a, the variable only a, which we notated as the leading coefficient that we need to solve. So y is equal to ax squared. In order to solve this, all we have to do is input and solve for the output. This is our strategy to solve this. Which means when we input our value as 6, we need to get an answer 12. Then we're isolating our value a. So let's do it. When the y value, which is 12, is equal to a times x, instead of x, we input 6 squared. And the only reason why we could do it is because this quadratic function passes through our point B. So if we keep solving this, we'll get 12 is equal to 6 squared is 36, 36a. All we have to do in order to isolate is divide all of the term by a. We're going to get, by 36, we're going to get a is equal to 36 in the denominator, and then 12 in the numerator, which we're going to get 1 over 3. We solve for a function as well as a variable. Our quadratic function will be y is equal to, instead of a, we input 1 over 3 x squared. And from here, we figure out one of our things that we need to solve, point A. And from now on, let's think about how to solve the point B, A. Because we know that they gave us the x value of our a, which is -3. So our point A will be -3, comma, y, where our x value exists and our y value we don't know. But we are applying our exactly same strategy that we used to solve for a quadratic function. We are using input, we input value, and we are going to get an output of a function which we notated as the y value, and we isolate things that we are trying to solve. So we know that our quadratic function is y is equal to 1 over 3 x squared. All you have to do in order to solve for a y value is simply input our x value -3 to our quadratic function. Y is equal to 1 over 3x squared. And the only reason why we could do this is the point A is a point that the quadratic function passes through. So if we input our x value as -3, we'll be able to get y is equal to 1/3. Instead of x, we input -3 squared. -3 squared will turn into +9. We'll be able to solve our y value, which is 3. So we're going to get our y value, which is +3. So instead of y, we're going to get 3. So we basically solve for our point A and the point B. Our point A was -3, 3. Our point B was 6, 12. So it's time for us to solve for our simultaneous equations. And the property or the thing that we need to solve our simultaneous equation is the variables quantity, which means how much the variable is, should be exactly same with the quantity of our equations. So variables quantity should be exactly equivalent with the equation's quantity in order to apply our simultaneous equation as we have talked about it in a lot of videos. So first of all, we're trying to solve for our linear function y is equal to mx plus n. All we have to do is we know that we have our two point A and B. So we need to solve for our two variables, two things m and n. We have our point A and B. So two equations with two things that we need to solve. So we could. This is the thing that we can apply our simultaneous equations. So let's actually think about 2 points A and B. Our point A, which is our -3, 3. Let's input this to our linear function. If we do it, we're going to get y. Instead of y, we have +3 is equal to m times, instead of x, we input -3, so it will be -3m. Plus, instead of n, we input exactly m. So this is our first equation that we have. 3 is equal to -3m plus n. Now, let's input our second point, point B. And our point B will obviously going to be 6, 12. If we input it to our linear function, we'll get y. Instead of y, we input 12 is equal to negative something, but we have our x value 6. Instead of x value, we input 6 m plus n. Here is our second equation. In order to apply our simultaneous equation, we know that the most important point in the simultaneous equation is we need to remove one variable in order to solve for one variable. In this case, all we have to do is subtract both of the things in order to remove our one variable n. If we subtract them, we'll get 3 minus 12, -9, is equal to -3m minus 6m, which will going to be -9m. And we'll get that if we divide all of them by m, we can get that m is equal to +1. This is what the m value will going to be. So our m value was 1 from our simultaneous equation. So we solve for m in order to solve for our n value, which is the last thing that we need to solve as the constant. Just simply input it to our original function. So our original function was y is equal to mx. Instead of m, we input n, so we're going to get x plus n, where m was 1. So from here, we know the x plus 1. But we are not inputting m in here. We are inputting it to our specific equation that we solve one of our equations here. So I'll just input as the first one because it looks simple. 3 is equal to -3m plus n. Instead of m, we input our positive positive 1. If you do it, we're going to get 3 is equal to negative 3 plus n. If we add 3 to the both sides in order to isolate our n value, we get n is equal to 6. This is the main point in our simultaneous equation. So our answer for this question will be m is equal to 1, n is equal to 6, a is equal to 1 over 3. This is the first thing that we need to solve. Let's think about the second one, which means we need to solve for our point P and the PQ. And we know that the point P is the P, comma, Y according to our information, which means we know that point P is also the intersection. So all we have to do in order to solve for a point P is simply input this value to our linear function. Because the intersection with the linear function according to the graph. If you do it, our linear function is y is equal to m plus 6. We input our p, instead of, it's not m, it's x. Instead of x, we input p value. So the point P will be p, comma, p plus 6. Now let's think about what is our point Q. We know that the point Q is perpendicular, which means the x, according to its property, the x value exactly same, but a different y coordinate. So the point Q will be p, comma, y. But the point P, let's look at it again. The point P is on, what is it on? The picture is a little bit weird, but the question just said Q is on the quadratic function. This is what the graph should be. If it's on the quadratic function, we can simply input our Q value into our quadratic function and get our cube. And our quadratic function is y is equal to 1 over 3x squared. And then if we input our p value, we're going to get, instead of x, we are inputting p. We're going to get y is equal to 1 over 3 p squared. So this will going to be our y coordinate. This will be our y coordinate of our point P. So our point P will essentially going to be, so our point Q is Q, not P. It will going to be P, comma, 1 over 3 p squared. So the segment QP, or the PQ according to the questions, we know that point P is P, comma, Y. And our point Q is P, comma, 1 over 3 p squared. And as we have talked about in lots of videos, the line or the lengths between the points will be the difference between the points. There is no difference in the x value, there is a difference in the y value, but the point P was p plus 6. So the difference between them will be p plus 6 minus 1 over 3p squared. This is what our answer will going to be. P plus 6 minus 1 over 3p squared.